I'm going to talk to you a little bit about velocity and the different types of velocities, because not all velocities are created equally. First of all, there's speed and there's velocity. Okay? Your speed, you're going down the highway at 65 miles an hour. That's 65 miles distance per hour measured time. So to calculate speed, you would just take your distance divided by your time. The difference between speed and velocity is direction. You go down the highway at 65 miles an hour, that's speed. You go down the highway at 65 miles an hour, north, west, up, down, that becomes velocity. So in a way, the two terms are interchangeable, but velocity is what is known as a vector quantity, and direction does make a difference. Okay? If you're going down the highway at 65 miles an hour and somebody in front of you is going 60 miles an hour, you will approach them, okay? But your difference in speed will only be about 5 miles an hour. But when you meet somebody on the highway and you're passing them, okay, your difference in speed as you pass them is considerably higher depending on how fast they're going. The easiest type of velocity to talk about is constant velocity. Going down the highway with your cruise control on 65 miles an hour east, that would be a constant velocity. The equation D equals VT works really well with a constant velocity. Okay? Light travels at 300 million meters per second through the vacuum of space. That would be a constant velocity. It would not change speed until it interacted with matter. Okay? Now, let's say you're going down the highway at your constant velocity, 65 miles an hour, and grandma in front of you is going 55 miles an hour, so you're going to pass her. Right? You would then accelerate, okay? Acceleration, again, a vector quantity. You would then accelerate, you would get faster to pass grandma, okay? And then get back in front of her. Now, let's say that you're going down the highway 65 miles an hour, you come up behind grandma, you accelerate to 75 miles an hour, but once you get around grandma, you're liking going 75 miles an hour. Even though you're starting to slow down a little bit, the highway patrolman, boom, catches you right there. Now, when he pulls you over, he does not care what your average velocity was. He does not care what your constant velocity was before you started to pass. All he cares about is your instantaneous velocity, your velocity at that moment in time. And just an FYI, when the highway patrolman pulls you over, if he asks how fast you're going, never give him your speed in meters per second. That just upsets them. Trust me. All right. Now let's talk about acceleration a little more and your changing velocities, okay? So constant velocity, but if I put this ball on the ramp and let it roll down, put this ball on the ramp and let it roll down, that velocity does not stay the same. It changes because the ramp slopes down under the influence of gravity a little bit, and that will accelerate it. So if we hold, you can see this one better, we hold the ball up here and drop it, that would be a changing velocity. The ball would be accelerating. Right? We're at 0 meters per second here, and it speeds up until it hits the ground.